All right, in this video, we are going to look at reference angles in trigonometry, and in doing so, we're going to kind of make sure we understand what reference angles are and also the definitions of sine, cosine, and tangent. In particular, I'm assuming you're coming to this video having learned, hopefully, that you can define sine, cosine, and tangent in a different way. There's the right triangle way, right? Ratios of sides of a triangle. But the way I want you to think of it in this case will be more helpful. So let's just draw a circle right here. Okay, so let's say that's the unit circle. Okay, that's the unit circle, and let's think of generically, that's just a okay, we rotated an angle in standard position, so that's angle theta. And this point right here, again, so it's the unit circle, the hypotenuse is 1. This point here is x comma y. So, by definition, that distance here, this leg of the bottom leg of the right triangle is x, this height is y. By definition, the sine of theta is y over 1, which is y. The cosine is x over 1, which is x. So we can think of this point as x comma y, but also cosine of theta, sine of theta. In other words, any point on the unit circle can be thought of in Cartesian form, x comma y, moving like horizontally and vertically, but also in terms of the trig ratios, cosine and sine. Cosine is the x-coordinate of a point on the unit circle, corresponding to a given angle, and sine is the y-coordinate. And then we should note that tangent is y over x, right? It's the opposite over hypotenuse, opposite over adjacent. A good way to think of this is it's the slope of this line. Right? Because it's y over x, which is clearly a rise over run. So I'm going to use these ideas to do this problem here, or this sequence of problems. So this says express each of the following in terms of a reference angle. Okay, so a reference angle is always an angle, it's an acute angle made or formed with the x-axis. It's called the reference angle because we refer to it, when we're thinking in terms of triangles, we refer to it to actually use the definitions, the trig definitions, to do these problems. So, sine of 700 degrees. Well, the first thing to notice is that 700 degrees is coterminal with an angle that's smaller than it. So to find an angle that's coterminal with 700 degrees, we're going to minus 360 degrees, because rotating 360 degrees brings you back to wherever you ended. And of course, that's the sign is going to be the same regardless. So sine of 700 minus 360, so 700 minus 300 is 400, minus a 60 gives you 340. So this is the sine of 340 degrees. So we're not done yet because this is not an acute angle, but let's just draw what we would get. If you rotated 340 degrees, that's almost a full 360, but you missed, right? You were just shy about 20 degrees, or not about, you were shy 20 degrees. So the reference angle there is 20 degrees. I'm going to zoom in on this a little bit. The reference angle is 20 degrees. Again, we want to think of sine as the y-coordinate, right? Sine is the y-coordinate of a point on the unit circle. So if I were to just write the answer as sine of 20 degrees, that wouldn't be correct, because 20 degrees is actually in quadrant 1. Right? This is actually a rotation of 20 degrees. And the y-coordinate there is positive. So since we're dealing with the sine of 340 degrees, we note that this y-coordinate, right, that's the sine of 340 degrees, that is the opposite y-coordinate of the sine of 20 degrees. So in order for me to correctly identify what the sine of 340 degrees is as a reference angle, I can't write sine of 20 degrees because that's a positive y-coordinate. We have to negate it. Okay, the sine of 700 degrees is the same as the sine of 340 degrees, which is the opposite of the sine of 20 degrees. And note, 20 degrees is a reference angle. And we're done. That was the directions. Let's try with cosine. So cosine of 128 degrees. Let's rotate 128 here. So that brings you, it brings you shy of 180. So it brings you maybe here, we'll say. That's 128 degrees. So what that means is the reference angle would be this here. Remember, the reference angle is the angle made with the x-axis. So that's this angle right here. This is 180 minus 28. 128 is 52 degrees. So the cosine of 128 degrees is the x-coordinate of this point. But the x-coordinate of this point is this. So that's the cosine of 128 degrees. This length right here, it's a negative x-coordinate. If I want to express it as a reference angle, in terms of a reference angle or equal to a reference angle, I can't write just positive. I can't say that that's the same as the cosine of 52 degrees because 52 degrees specifically lands in quadrant 1. So 52 degrees would look like this. That's 52 degrees. Cosine of 52 degrees is this positive, is that positive distance, positive x-coordinate. These lengths are identical but opposite. So in order to express correctly the cosine of 128 in terms of a reference angle, I need to negate that. So cosine of 128 is negative cosine of 52 degrees. Let's take a look at tangent. I don't know why these are so separated. I'm just going to rewrite it down here if I scroll. So let's do 160 degrees. So 160 degrees brings us just 20 degrees shy of 180. So let's just say that's where we are. So this is 160 degrees. And I'm going to draw that. Let me zoom in here. Oops. Sorry. Let me zoom in here. So this is 20 degrees. Now, I want you to extend this line here. I want you to think of that line as going all the way through. So what do we know? We know that this is 20 degrees as well, right? And as we learned up here, we want to think of tangent as the slope of the line through the origin, right? Tangent is the slope of the line through the origin. So the slope of this line, I'm going to write that slope, we can say is equal to the tangent of 160 degrees. Okay, it's a negative slope, so therefore tangent of 160 is negative. 160 is not a reference angle. 20 degrees is. So let's see how we can kind of make these equal. 20 degrees would be here. Right? So the slope of this line is equal to tangent of 20 degrees. Now that's a positive slope, and whatever the slope of this line is here, I'm going to just put in some numbers. Let's call this, let's just call this A and this B, right? So that's A over B is also the slope. We can see that, well, let me just kind of connect these. I know that's not quite to scale, but if this is A, this must be negative A, right? And this length here must be negative b. If you do the slope of the pink line, you get negative a over negative b, which is the same as a over b. But because this triangle here is congruent to this triangle here, and again, they're congruent because that angle is 20 degrees, this is 90 degrees, this is 20 degrees, that's 90 degrees, though they're congruent. That means all the sides are equal. So if this is negative b, this side here must be a. And the slope of that line, therefore, is a over negative b. But that's precisely the opposite of this. So the punchline is that the tangent of 20 degrees is the opposite of the tangent of 60 degrees. The slope of the blue line is the opposite of the slope of the pink/purple line. So we write negative tangent of 20 degrees. And again, remember 20 degrees because, well, that's a reference angle. So these are kind of priming you mainly for identities that you're going to learn later, but they can all be gleaned from drawing pictures. Now, so far, all the examples I've done involved negating, right? In order to make true statements, we had to negate the expressions involving the reference angles. That doesn't always happen. Here's an example where it wouldn't happen. The cosine of 320 degrees. So 320 degrees takes us here, takes us 40 degrees shy. It takes us 40 degrees shy of 360. Again, the cosine, I'm just going to draw this line here. The cosine of 40 degrees is the x-coordinate of this point. In fact, you could even, if it helps, write cosine of 40, comma, and then the y-coordinate of this point is sine of 40. We don't really need sine for this problem, but so that means that this length right here, I'm going to highlight in yellow, that length right there is the cosine of 320 degrees. Oops. Okay, it's the x-coordinate when you rotate 320. How can you express that in terms of the reference angle 40 degrees? Well, 40 degrees is here. Let's see how they relate. Well, if that's 40 degrees, these triangles are clearly congruent, the red and the blue/pink, which means their sides are equal. But they share this side right here. So again, this point you can think of as cosine of 40 degrees, sine of 40 degrees. But the key idea is that the x-coordinates here, right, this x-coordinate is this length, but so is, oh, you know what? I goofed. This is not what I meant. Sorry, fix this. It's supposed to be 340 degrees. Or 320 degrees. My bad. But in any case, the x-coordinate is cosine of 320 degrees. The x-coordinate up here is cosine of 40 degrees. We can tell those are the same x-coordinate. So we can say that cosine of 320 degrees is equal to the cosine of 320 degrees. So this time there's no negation necessary. Okay, the cosine of 320 degrees is the same as the cosine of 40 degrees. And again, that's because we can see from the picture that this distance is the x-coordinate for both of these points. Both of these points we see in the picture. So that is kind of priming you for some identities. Again, the key idea is if you use the unit circle here, you want to think of lengths and distances as having positive and negative signs associated with them, and then start to reason a little bit, either using congruent right triangles, or in the case of tangent, using slopes.